Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about chapter 9F in your differentiation part. This lecture actually made of some mathematical problem. All of you are requested to keep writing when you are watching the video. Okay, let's have a look at today's class. So dear students, according to our lesson plan, today we are going to discuss about some mathematical problem on chapter 9F. Our first mathematical problem is example 2. That is, if tan y equal 2t divided by 1 minus t square and sin x equal 2t divided by 1 plus t square, then determine dy by dx. My dear students, here we have seen tan y is the function of t. Here similarly sin x is the function of t. That means we have to derivative this two part first of all by or respect to t. How we can go for it? Okay, here is given two part, so our solution can be like this. Our given part is tan y equal 2t by 1 minus t square. So from here we can write what? Y can be written as tan inverse 2t divided by 1 minus t square. So dear students, we know two formula from our trigonometric section, that tan inverse 2x divided by 1 minus x square was 2 tan inverse x, and we have learned another formula, that is sin inverse 2x divided by 1 plus x squared is 2 tan inverse x. We'll actually use these two formula in here. So first of all, here is given tan inverse 2x divided by 1 minus x square is 2 tan inverse x is our first formula. So if we use this, then what we'll get? We'll get 2 tan inverse t, since here is given 2t divided by 1 minus t square. So we get that the value of y is 2 tan inverse t. Okay, so what is given in our next part? Again there is given something, what? That is sin x is equals to 2t divided by 1 plus t square, and here we can write x is equals to sin inverse 2t divided by 1 plus t square. My dear students, I think you all can understand that sin inverse 2t divided by 1 plus t square can be written as 2 tan inverse t. Why? Because of this formula. We know sin inverse 2x divided by 1 plus x square is nothing but 2 tan inverse x. Just use this formula in here, then what we will get? Exactly 2 tan inverse t. So here we have observed two things. One is y equal to tan inverse t and x equal to tan inverse t. Since our two right sides are equal, then we can say x and y must be equal. So if we are giving here the equation number 1 and it is equation number 2, then what we can say? We can say from 1 and 2 we can write from the equation 1 and the equation 2, we can write what? Y is equals to x. Exactly, y is equals to x. Now if we are trying to derivative this with respect to x, then what we can write? ddx of y, ddx of x. Differentiate with respect to x, you have to write it. differentiate with respect to x, this side note must have to be given here. Now what we'll get here? We get d dx of y is equals to 1. And now that's our required answer or value. Okay, so this is how we can solve our question number 1. Now we are going to move on our next math for this lecture. So dear students, that is our second problem from this lecture. Here what is given, x power y is equals to y to the power x. We have to find dy by, d dx of y. How we can solve these types of problem? We can solve these types of problem by this way. Here is given x to the power y equal y to the power x. When we have seen that two functions are remain something power something and both two are the function, then we will take both side as ln. If we take both side as ln, then you can fit ln x to the power y equal ln y power x. And we know our formula, that is, if ln x to the power, say for example m, then we can write m ln x, because this is the formula of logarithm which you have been already learned in your class 9-10 level. So now what actually happened by using this formula? Here we'll get y ln x equal x ln y. Now we are going to differentiating this line with respect to x. So if we are try to derivative this line is with respect to x, then we can write d dx of y ln x is equals to d dx of x ln y. And we must have to write a side note like this, differentiating both side with respect to what? Exactly x. Differentiating both sides with respect to x. Okay, now we're going for, here we have been observed that two functions are in here. One is u and this is v. So we'll go a formula of dx of uv formula. So we'll think that this is our u and this is our v. So what is the formula of d dx of uv? We know d dx of uv is nothing but or u d dx of v plus v d dx of u. So we'll use that formula in here. Then we can write u d dx of v, that is ln x, plus v d dx of u. Similarly in here we'll think that our this function is u and this is v. So d dx of uv should be, again we can write like this way, that u d dx of ln y, that is u d dx of v plus v d dx of u. If anyone have any problem, then I can give you the formula here. Actually we are trying to focus on d dx of uv equal u d dx of v plus v d dx of u. My dear students, I think you all know this formula very clearly. Okay, so now what we will get from here? Y, what is the formula of it? D dx of ln x is nothing but the 1 by x plus ln x d dx of y equal x. Here is ln y, that means 1 by, we'll consider here actually, we'll consider here the y as x. Then what is the formula ddx of ln x? Exactly 1 by x. So we'll write here 1 by y, since this is not our original x, that's why we're going for again the differentiation of this, that is ddx of, since y is our not x, that's why we'll differentiate it again, plus ln y, and you all know that ddx of x is nothing but exactly 1. Now we get y by x plus ln x ddx of y equal x by y, we'll get ddx of y and ln y. Now since we need to find the value of dy by dx, that means ddx of y, that's why we need to take these two part in one side and this two should be the other side. Then what we can actually write from here? So ln x dy by dx ddx of y minus x by y ddx of y. Then write it here ln y minus y by x. So here we'll just try to take common, then we can write ln x minus x by y, and this should be common ddx of y. Then we can write ln y minus y by x. Here ddx of y should be ln y minus y by x divided by ln x minus x by y. Now we can write it as our answer, but the smartest way to going for the LCM in the numerator will be get x ln y minus y, then it should be y ln x minus x, and finally we'll get x ln y minus y divided by x into y, and here we'll get y ln x minus x. So that's our ddx of y, ddx of y. So the answer of it should be y x ln y minus y divided by x into y ln x minus x. That is the answer of dy by dx, that is ddx of y. So dear students, that is our last math for this lecture. So here our last question is question number 15, and here is given ln xy equal x plus y. We have to determine the value of ddx of y. How we can solve these types of math? Okay, we can solve this math by, it is given something. So given log natural or ln of xy should be x plus y. So here we have seen that here is given some part with two variables, and similarly here is also the same thing. Here is x and y, here is again x and y. So we'll differentiating both sides with respect to x is our first work. So we'll try to focus on ddx of ln xy is equals to ddx of x plus y. What we have been trying to focus on? Exactly differentiating both sides with respect to x. So if we derivative this, then what will we get actually? We can write ln of x is 1 by x, that means 1 by xy. Since this is the part is not the exact x, that's why we'll exactly differentiate this part again. We'll get d dx of xy is equals to, we know d dx of u plus v equals to d dx of u plus d dx of v. That means we're trying to focus on this is actually u and this is actually v. Now we can find here uv formula, that will be u d dx of v plus v d dx of u. So what we are trying to focus on? We are assuming that x is actually our u and y is actually the v. So u d dx of v plus v d dx of u. And what is our right side? It should be 1 and here d dx of y. And here what we have been found, we are observing here that 1 by xy is x d dx of y plus 1, because d dx of x is exactly 1. So 1 plus d dx of y. Now if we multiply this, then here we can understand that x's will be cancelled, then it will be 1 by y d dx of y plus y cancel 1 by x, and here 1 plus d dx of y. So here we have found two functions or two part where we can find that d dx of y, what value actually we are trying to finding. So take this part in our left side. So 1 by y d dx of y minus d dx of y equals to 1 minus 1 by x. Now if we take common here, then what we can write? So from here we can write by taking common dy by dx, it will be 1 by y minus 1 into d dx of y is equals to 1 minus 1 by x. So d dx of y should be 1 minus 1 by x divided by 1 by y minus 1. So it should be, if we are trying to LCM x minus 1 y, so 1 minus y. Finally we get x minus 1 into y, y minus y into x. So that is d dx of y, what we had to find. So this is how we can solve these types of math. So dear students, this is how we can solve these types of maths, and hopefully this lecture will be very beneficial for you. All of you are requested to write this math when you are watching this video. Okay students, stay home, remain safe. Thank you.